Let's go ahead and try another percent efficiency equation. And this time, let's go ahead and play with a second class lever. And so we know a second class lever has the fulcrum off to one side. So let's go ahead and put that on the left. And let's say we have a force resistance that we're trying to overcome of, let's go ahead and call it 250 pounds. And let's say we only have an effort force of 120 pounds is our FE. And let's say our distance from our force resistance to our fulcrum, or in other words, our distance resistance, let's say that's 1.5 feet. And then let's go ahead and say our distance to our effort force from our fulcrum. Let's go ahead and call that, well, that would be our distance effort, by the way, of course. Let's call that 3.5 feet. And then I'm going to ask you, well, what is the percent efficiency? So percent E equals question mark. And then to solve, we need to find our AMA and our IMA. Well, we already know our equations for our AMA and our IMA, so let's start with our AMA. Our AMA is AMA free, or AMA equals FR over FE. And I think I just broke the record for the most times you can say AMA in under 10 seconds. But we know our FR, that's 250 pounds, we just said that. And then we know our FE as well is 120 pounds. And so to figure out what our mechanical advantage is, we'll go ahead and type this into our handy-dandy calculator. Let's say 250 divided by 120. And we get a mechanical advantage of 2.083 repeating. Okay, and then we'll go ahead and cross out pounds, and we'll say 2.08, we'll round up. Round down to 0.8, just to keep it simple. And then we'll go ahead and solve for our IMA. And our IMA equation, of course, is IMA dr, or IMA equals DE divided by dr. And of course, we know our DE. We already found that, or we already said that. It's 3.5 feet. And we know our, that was our DE. I'm sorry if I said dr. We know our dr is 1.5 feet. And to figure this one out, we'll go ahead and type that one in our calculator as well. We get 3.5 divided by 1.5. And what do we get? We get 2.3 repeating. Okay, so let's go ahead and cancel out feet. And let's say 2.33. And let's go ahead and round it to the 100th place, just like we did to keep it consistent. But from here, all we really have to do is just plug in our numbers. We have everything we need. We just type in percent E, or not type in, we write it out. Percent E equals, well, it equals this equation. Let's go ahead and give ourselves two big parentheses and a divide by. And on top, we'll put our AMA. We'll put 2.08. And on bottom, we'll put our IMA. We get 2.33. And of course, we'll multiply that by 100. And to get this, what we're going to do is we're going to type it into our calculator. Let's go ahead and open a parentheses like we have. And let's hit this button, this numerator divided by denominator button. And on top, we can put 2.08. And on bottom, we can put 2.33. And then we'll leave and close our parentheses, and we'll multiply that by 100, just like it's written. And that's what I like about these calculators. And what do we get? We get 89.27. And we'll go ahead and round that up to just 89.3% efficient. What does that mean? Well, essentially it means we lost a little bit over 10% of our effort force, or of our energy, from this system. And so hopefully that's too easy, too obvious for you. But real quick, let's talk about a concept. What happens if we rounded differently? What if we rounded these to one decimal place? What if we got 2.1 and 2.3? How would that change our answer? So now on top, we would put, 2.1. And on bottom, we would write 2.3. Let's see how that changes our answer. So we close it and multiply that by 100. And that would change our answer and give us 91.3%, which would be quite a bit. Adding 2% efficiency to a system is actually pretty good. But unfortunately, we can't just do that by rounding. But my point is, rounding is actually pretty important here. And depending on how you round, you'll get a whole range of values that could be correct. And so if you're not told how to round, if it's not made specific for you, made obvious for you, then clearly we would accept a range of answers somewhere within these two values. But if it is clear, the more precise the rounding has to be, the more precise your answer has to be. But we'll talk about that concept in future videos.